Now we will look at how to attack the Shift cipher. The lecture today will be given by Eve, or EveAttacksShiftCipher, as she is known in Gaul.
Welcome to Gaul. I am EveAttacksShiftCipher. Today we will look at the four main categories of attacks that I can use to try to understand and decode encrypted messages. Let us now look at the four main types of attacks. Ciphertext only. I have only the ciphertext. The challenge for us is how do we get back the plaintext or the key with only some ciphertext. Known plaintext. In this case, we have one or more pairs of ciphertexts and their matching plaintexts. This gives us a better starting point for trying to find the key and to decipher future messages. Chosen plaintext. Now this is where it gets fun. For a brief time, I cleverly got access to the cipher. How? By the magic of the oracle. Using this, I was able to choose my own plaintexts and make matching ciphertexts. Chosen ciphertext. This is like chosen plaintext. However, in this case, I get to feed in my own choice of ciphertexts and see their corresponding plaintexts. In a ciphertext-only attack, we only have the encrypted message. How did I get the message? Perhaps I captured one of Julia's messengers. The first thing that we can try is what is called a brute force attack. That means we try all of the possible decryption keys. How does that work in this case? It is simple. We take the ciphertext and unshift by one letter. Next we unshift by 2 letters. Then by 3 letters. And so on. If we look at all of the possible decryptions, we will see that only one of them makes sense. There we go. We got it. Julia was telling Bobbicus that Gaul is divided into 3 parts. Another type of ciphertext-only attack is what is called a frequency analysis attack. In this type of attack, we look at the ciphertext and count how many of each type of letter we have. Since the letter E shows up the most often in English messages, it stands to reason that the most common ciphertext letter was probably shifted from the letter E. Or, if not, then perhaps it came from the letter T. This gives us a reasonable guess for the shift key. For example, if L was most often in the ciphertext, then shifting E by 7 would give us L. Thus the key is probably 7. Now we just unshift by 7 and see what we get. The second category of attack is the known plaintext attack. If we know one letter of the plaintext and the corresponding letter of the ciphertext, then we can figure out the shift key. Suppose we know the letter T encrypts to D. T is equal to the number 19. D is equal to 3. Then K equals 3 minus 19 modulo 26, which is 10. Now we can use K equal to 10 to decrypt the rest of the ciphertext. The next type of attack is the chosen plaintext attack. For this attack, we get to choose the plaintext and encrypt it to see what the corresponding ciphertext is. You might ask, why would Julia ever allow us to encrypt our own message as well? There are many reasons why this might happen. For example, maybe she and Bobbicus have an arrangement where he sends her a message and she sends back the encrypted version. Believe it or not, this happens a lot in modern communication protocols. So, what I will do is send a message to Alice, pretending to be Bobbicus, and she will encrypt it for me. When I do this, I am conducting an oracle attack. Let us be clever and send Julia a message to encrypt and give back to us. If we choose the letter A, then X equals 0. This will encrypt to Y equal to K. Therefore, we get the encryption key back as the ciphertext when we use A. Clever, right? Julia gave us her secret. Silly Romans. The last type of attack is the chosen ciphertext attack. Here we get to choose the ciphertext and see what Bobbicus decrypts it to. Bobbicus is now the one acting like an oracle. Now let us send Bobbicus the ciphered text A. He will decrypt this and give us the negative value of the encryption key. Of course, we can use this to decrypt future messages. Silly Romans.
In the next lecture we will stop and spend some time reviewing some math concepts, such as basic number theory. We will need it.